Apa? Mau meeting.
Maaf. Mantap, An. Cobain PPT-nya, An. An, cobain share screen, An. Oke, mantap, An. Sip, sip.
Jadi meeting orang.
Ibunya belum masuk.
Iya, besok baru buka.
Nggak kelihatan kakak. Bukan kakak.
Sudahan.
Aman, sudah.
Mulaikah sekarang?
Langsung.
Ya, langsung aja.
Ada kak. Angger. Beneran langsung nih udah nih. Ibu kok nggak ada?
Ibu nggak ada nih. Latihannya berkali-kalian. Terus nanti di sini ada sesi tanya jawabnya, jadi tolong diperhatikan dan disimak. Apabila ada yang ingin ditanyakan, boleh ditulis kolom komentar. Nanti pas sudah selesai presentasi akan dijawab oleh Anda. Waktu dipersilakan kepada Anda Sumardi untuk mempresentasikan papernya. Silakan Ana.
Ya. Aduh, aku juga kan. Tunggu. Ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Good morning, everyone. Good morning, everyone. I'm going presentation about our research. The title is Design the Mesoporous Hybrid Organosilica Thin Film Prepared from Organic Catalyst. Before start, let me introduce myself. My name is Ana Sumari from Lambung Mangkurat University.
Bisa kak video mukamu nyalain supaya tahu.
Tar.
Ntar dikira baca.
Ya. Dah.
Ya, dah sip.
Aku nggak bisa di next, tunggu kak. Yeah. This is our background. The use of membrane. The use membrane apply desalinasi. One of technology except the future to produce clean water. However, the next lead to do future research content in film for use in desalination. A suitable structure for this application to produce mesoporous high hydrostability, strong bond between matrix, so that the deserved structure is very important to type material use. Purpose research use the CTP, technical CTP calcination. In this research use different technique calcination. This research use the ATP calcination to produce the ATP calcination as use organic catalyst, namely is citric acid. This organic acid function as carbon source and double precursor sort as silica bonds to produce silica carbon to make a strong structure. Strong structure increase hydrostability. One of the advanced RTP over CTV. In RTP, there are a little use energy because RTP just use 1 hour to make one layer thin film. And the next is objectivitas. The first to investigate the calcination temperature effect. T50 350 and 600 degrees C. And then the second, compare the use of single catalyzed citric acid and dual catalyzed citric acid ammonia in thin film fabrication. This is initial work. The first salt gel process. Salt gel process. The first we mix TeOS, TVS as a precursor and ethanol as a solvent. Mix in 0 degree C, and we add citric acid, 50 degrees C. And this process called the hydrolysis. The hydrolysis to produce gugus function silanol to make a micropore structure. And the next we add ammoniac as a base catalyst to make a process water condensation to produce gugus function siloxane. Siloxane make micropores in structure. The next is silica salt, drive strogen to 24 hours at 60 degrees C. And then we make soil to powder, and we calcinate soil at 353 and 600 degrees C in the air with a furnace. And then we characterization, FTR, BT, and TGA. And the next is the slide show the material and equipment we use in this research. The first, there are oven, analytic balance, hot plate and stirrer, furnace, reagent bottle, and the material is citric acid, TeOS, TPS, ammoniac, and ethanol. And the next is result and discussion. This is a characterization FTR. There are two graphic. The right side different sample, but same with temperature calcination at 350 degrees C. In the blue line show with base, and the red line show the without base. And the right side show the calcination at 600 degrees C. This analysis, the characterization FTF proved 4 sample have three gugus function. There are silanol, siloxane, and silica carbon. Silanol we can find at wavelength 160, and the silanol range around 900, and silica carbon and 800. And the next is stable. The residue and vibration bonds are using physics software. The physics software. This show use the principle of Gauss length forming lengths a peak that normalized of baseline. It mentioned the area segment or precursor function group. The biggest different purpose is silica carbon. Purpose research. The biggest is the sample without base at 350 degrees C, 2.13, and the purpose research just 0.37. So it's proved we use dual precursor make increase gugus function silica carbon. And the next is deconvolution peak area from silanol per siloxane and carbon. Two sample make a different trend. The blue show dot blue show the without base sample in increased temperature calcinate increase to silanol per siloxane and silanol per carbon 2, but different or offset with sample with base. With base when we increase temperature, but peak area rasa silanol per siloxane is increasing. I think it's because the concentration of cis acid we use is different. With dot base we use concentration citric acid at 0.1 normalitas, and the other sample with base 0.001 normalitas. And the next is TGA analysis. In the blue one, the sample without base, and you can see there are 3 stages. The first stage is show the evaporation, and the stage 2 show the transition, and the stage 3 show the decomposition. The stage first evaporation make silanol or gugus function OH evaporate and change SE silica. So make gugus function siloxane, and the transition has silanol remaining group 2 has been evaporated at stage 1, and some carbon decomposition nearly fed in up to 400 degrees C. And at high temperature with base is better than without base, then because the less of mass produced for without base, while with still has mass 70%. It's proof the material with single catalyze is citric acid at addition with give excellent temperature compared to citric acid ammonia. And then BT characterization. This graph show the height surface area have with the base, the sample without base at 600 degrees C. And but the pore diameter the highest, the same sample, but different temperature calcinate. Per diameter, the highest per diameter is the 0.59 nanometer. The sample without base 350 degrees C. Another research show the highest surface area in silica P123 at 350 degrees C using CTP. But per diameter make a mesopore size range. When we apply desalination, is not matched. So without base at 600 degrees C is the best sample we have. And this is our conclusion. The first, the use of precursors has successfully to produce an interior-free membrane which has a high carbon bond structure, increase increase the hydroxide of the membrane. There are three function groups: silanol, siloxane, and silica carbon. And the third, based on the result, TGA sample with the base are very good at low temperature, less than 90-50 degrees C. And the last, organosilica made a single catalyzed citric acid without the addition of base has the highest surface area of 6,042 meter square per gram at 600 degrees C. This is our acknowledgement, and special thanks to SISTEC M2ReG, dan Lambung Mangkurat University. And thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Wabarakatuh.
Okay, thank you for Anna. Now, we open questions for the all. Please, all of participants, please ask me questions. And Anna will answer one by one.
Suaranya nggak jelas.
So let the participants ask questions to Anna. Anyone? Okay, Anna. I would like to ask you two questions. So first, why are you
Tunggu.
apaan?
Nggak jelas suaranya. Dah.
I would like to ask you two questions. No. First, why are you choose MTS to modify your membrane?
Why are you choose TPS?
And yes, sorry. Why are you choose TPS to modify your membrane?
The first, TPS has TPS have aduh apa tuh? Have multiple bonds silica, because has TPS have multiple bond silica to make silica carbon bonds increasing hydrostability too. But when we eat TPS 100%, make Srogel have microporous structure. So in this research, just use 10%. Gitu Kak.
Okay, thank you, Anna. And so here the Enggar ask you a question. Why the materials without acid would be the better one than using a base? And then how could adding a base catalyst make a lower pore diameter than you add an acid? So you also say your presentation was simple. You can read the question on the comment.
Yeah, yes. Why the material could be the better when using this? And without acid, we use without acid the base rather than with base, because in the sample without acid have a lot of carbon. Carbon, and in sample without acid, concentration high than with base. Without acid to have TGA analysis. So just mass loss-nya just around 30%. So the without base acid better to application with the higher concentration per evaporation. Pokoknya ya itu aja Kak. Terus, then how could add base catalyst make flower per diameter? Then you add I think when we add base catalyst, make a lot of siloxane, gugus function siloxane, and gugus function siloxane make oh yeah. Sorry, I mean without base, and because you compare both with or without base. Maksudnya Kak Enggar, jadi maksud Kak Enggar, I mean without base and
So Enza asked about why the Carogel without acid is better than without acid, or only without base. Carogel without base, why better than with base?
in application when we apply usually biasanya kalau di aplikasi tunggu. We can see the TGA analysis why the without base better than with base. The first is prove the TGA analysis. When we application with the highest temperatur, maksudnya ketika diaplikasikan yang tinggi emang bagusnya without base Kak, karena kalau diaplikasikan di perpap, karena hasil TGA-nya mass loss-nya lebih rendah, ya enggak sih, gitu Kak. Apa Kak?
Which acid do you use? What type of acid?
Ulangin.
Kamu pakai asam apa? What type of acid? Nah, citric acid has a carbon content kan?
Yes.
Nah, that's why dia kasih
The-
lebih bagus hasilnya kan?
Yeah.
Fokus di situan.
Tapi, but the two sample make but two sample used to citric acid to different sample